students. Welcome to today's session of chemistry. As you all know, we have started study of seventh lesson of your syllabus, that is modern periodic table. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we learned about the blockwise characteristics of all the elements. As you know, there are about 118 elements in the modern periodic table, and those elements are distributed in four different blocks, and they have general outer electronic configuration according to their block. The properties are the characteristics of the block they belong. We have learned that in detail about all the blocks, that is S block, P block, D block, as well as A block in the previous session. Now, in this session, we are going to learn about the periodic trends in elemental properties. We will study that in detail. So let us start with. Now, as you know, the original structure of the periodic table was based on the observed periodicity in the elemental properties. What is periodicity? That means after some period, the property is repeated. Thus, elemental properties also, they show similarity in a group, and they show gradual variation in a period or across a period. If we move from left to right, there is a gradual variation in elemental properties. Now, if we consider the model of an atom, that will explain the observed periodic trends of these elemental properties. So, in this section, we are going to discuss the periodic trends in some physical as well as chemical properties of the elements, and we are going to correlate them with the electronic configuration as well as with the nuclear charge. What is nuclear charge? As I told you, if we see the model of an atom, then we'll understand what is nuclear charge. The positively charged protons, those are present in the nucleus, they actually belong to that nuclear charge. Now, these trends, that is the periodic trends in physical and chemical properties, are explained in terms of two fundamental factors. Number one is attraction of extra nuclear electrons towards the nucleus, and secondly, the repulsion between electrons belonging to the same atom. You see, there are two forces acting simultaneously. The first one is attractive force and another is repulsive force. Attractive force, that is between the positively charged nucleus and the negatively charged electrons revolving around the nucleus. And which is the repulsive force? That is the force which is there because of the similarly charged, that is negatively charged electrons. So the repulsive force is in between the electrons, while the attractive force is in between the nucleus and the electrons. These two forces operate simultaneously in an atom, and hence that results in two interrelated phenomena such as effective nuclear charge and screening effect. So these two phenomena, that is effective nuclear charge and screening effect, are related with these two types of forces. Hence, we will learn in detail about these two phenomena. Those are effective nuclear charge and screening effect. So for that, basically we must know what is nuclear charge. In a multi-electron atom, the positively charged nucleus attracts the negatively charged electrons around it, and there is mutual repulsion among the negatively charged extranuclear electrons. Multi-electron atom, I said. Multi-electron atom, that means when the atomic number increases, the number of protons in the nucleus as well as the number of electrons in the shells that goes on increasing. So such an atom which is having a multi electrons, the positively charged nucleus attracts those electrons, and there is a mutual repulsion amongst the negatively charged extranuclear electrons. The repulsion by inertial electrons is particularly important. Inertial electrons, because the outermost shell, or we call it valence shell, it has the inner core has completed shells. There will not be any change that will occur after reacting with another atom. But a change may occur in the outermost shell. So the repulsion by inertial electrons is very important. And that results in pushing the outer shell electrons further away from the nucleus. The electrons in the inner shells, except that valence shell, they push the outer shell electrons further away from the nucleus, and thus these electrons are held less tightly by the nucleus. That means the attraction of the nucleus for an outer electron is partially cancelled because of the inner shell electrons. Outer shell electrons, they does not experience the actual positive charge present on the nucleus, because that positive energy is utilized by the inner shell electrons. The attractive forces, they get distributed amongst the inner shell electrons, and hence the electrons in the outer shell, they actually does not experience the actual positive charge present on the nucleus. Hence, the net nuclear charge actually experienced by an electron, that is called as effective nuclear charge. Understood? The first factor, effective nuclear charge. It is written like ZEFF as a subscript. So Z effective, we can say, the effective nuclear charge, it is lower than the actual nuclear charge. Actual nuclear charge, it is only Z. Effective nuclear charge is Z effective. Thus, the effective nuclear charge, we can say the effective nuclear charge is lower, that is Z effective is lower than the actual nuclear charge. Why? Because of the inner electrons. These inner electrons shield the outer electrons from the nucleus to a certain extent. This effect of the inner electrons on the outer electrons is called shielding effect, or it is called as screening effect, screening or shielding effect of the inner electrons, or those are called as core electrons. That means these electrons which are in the inner shells, they actually shield or act as a screen, and hence the positive charge of the nucleus will not reach to the outer electrons, and thus they are held less tightly, and hence the electrons are easily, or we can remove them easily by applying less energy. We are going to see that energy also. Now, we will see in detail about the effective nuclear charge. This effective nuclear charge, that is Z effective, is actually equal to Z minus electron shielding. Z is actual nuclear charge minus the electron shield. Suppose that electron shield is located by sigma, Z minus sigma, it should be actually sigma, is called shielding or effective nuclear charge. Z minus sigma is called effective nuclear charge. What is sigma here? Sigma is called shielding constant or screening constant, and the value of sigma depends upon the type of orbital that the electron occupies. We know that the electrons, according to their energy, are revolving around the nucleus in various energy shells. So, So this value of sigma depends on the type of orbital that the electron occupies. This effect of the inner electrons on the outer electrons is called screening effect or shielding effect of the inner core electron. Understood? So what is effective nuclear charge and screening effect? So now, what happens if we move down the group or across a period? If we move across a period, actually what happens? Across a period, the electron is added to the same shell. Actually, the nuclear charge increases by +1 at a time. We know the arrangement of periodic table. From left to right as we move, the electron or every time a nuclear charge it increases by 1 or increases by +1 at a time. And that the newly added electron gets accommodated in the same shell because we have seen the arrangement. Second period, second shell gets completed. In the third period, third shell gets completed. That means when we move from left to right across a period, every time an electron and a charge is increased by 1, but that electron goes to same shell. What happens to then effective nuclear charge? There is no addition of electrons to the core. Inner core is same. There is no change in the inner core, but the electron is added to the outermost shell. That means a charge in the nucleus is increased by 1, same time an electron is added to the last shell. But the shielding due to core electrons remains the same. Actual nuclear charge increases, but the shielding remains as it is. And what will be the effect then on the effective nuclear charge? That will go on increasing across a period. Because shielding effect, the value of sigma remains same, but Z goes on increasing. And we have the formula Z effective equal to Z minus sigma. So Z effective, Z remains as, Z increases by 1 unit, S remains as it is, and the result is, as we move across a period, the effective nuclear charge goes on increasing. Now, what happens if we move down a group? Down a group, what happens to effective nuclear charge? Actually, Z effective decreases down a group. Why? Because as we move down a group, a new larger valence shell is added. Every time a shell is added, when we move down a group, we have seen that in detail. So when we move down a group, suppose take an example of first group, hydrogen 1s1, second lithium 2s1, sodium 3s1, potassium 4s1. So 1s1, 2s1, 3s1, 4s1. So every time a new shell is added. And as a result, there is an additional shell in the core. So inner electrons, there is increase in the inner core as well. That means screening effect increases. The shielding effect increases as the number of core electrons increases. And hence, because of that, the effect of the increased nuclear charge felt by the outer electrons, that is decreased, and thereby the effective nuclear charge decreases largely down a group. Because again use the formula Z effect equal to Z minus S. Z is increasing. Okay. What about S? Sigma is also increasing. Why? Because every time a new core of electrons is added, and hence the result is effective nuclear charge decreases down a group and it increases across a period. Understood about these elemental properties? Now, so the assignment for this time, explain the terms effective nuclear charge and screening effect and how they change across a period and down the group. This will be the assignment for this time. And students, please send the answers of these assignments on my personal number only. Thank you.